Hello everyone. My name is Raviranjan Kumar, a fourth year student of Electronics and Communication Engineering at Guru Ghasidas Vishwavidyalaya. Today I am thrilled to present our IoT-based home automation solution. But before we start, I want to express my sincere gratitude to my project guide, Jayalakshmi ma'am. Her guidance and support were were instrumental in bringing this project to life. Thank you, ma'am. I would like to thank MXC Information Technology for providing me this opportunity to be a part of this IoT internship. During this internship, I built a project on IoT-based home automation solution, which I will be going to demonstrate further. This presentation, C and C++ programming, Internet of Things, embedded system, project requirements, garden light control, temperature system control, water tank management, and project screenshot and at last conclusion. So we have So first we have our first topic, C language programming. C programming is an essential tool to program Arduino board. It is a general purpose language even though it is applied and used effectively. Various specific domains. The topics that I have learned in this The topics that I learned in C is data types like char, int, float, double. Next, I have learned about modifiers and qualifiers. Modifiers such as short, long signed and unsigned, and qualifiers such as const and volatile. Next, I learned about conditional and loops. Conditional statements like statement, nested statements, and loops like while loop, for loop, and do while loop. I also learned about various operators like arithmetic operator, logical operator, and many more. Apart from this, I also learned about arrays, which is used to store elements of similar data types. And I also learned about pointers, which is used for storing the address of another variable, like int, char, float, etc. And I also learned about function storage and preprocessor directive. Moving further, I learned about Internet of Things. So what is Internet of Things? The Internet of Things is revolutionizing the way we live and interact with technology. By connecting everyday devices to the Internet, IoT enables them to communicate the collaborate IoT enables them to communicate and collaborate seamlessly, creating smart home, cities, industries. Imagine a world where your coffee maker start brewing as soon as your alarm goes off. Your car communicates with traffic signals to optimize your route. This is the power of IoT, enhancing efficiency, convenience, and innovation by bringing the physical and digital world closer together. What is IoT? The IoT refers to a network of physical objects. It can be anything, embedded with sensors, software, and other technologies to connect and exchange data with other devices and systems over the internet. This technologies this technology allows everyday object like refrigerator, lights, thermostats cars, and even clothing to communicate with each other and can be controlled remotely. Here are the some applications of Internet of Things: home automation, in, industrial Internet of Things, healthcare, IoT for healthcare, smart grid and energy management, smart education, IoT for agriculture, environment monitoring, wearable technology, connected vehicles, also known as VANET, smart cities, etc. So let's move towards embedded system. An embedded system is a combination of computer hardware and software designed for a specific function. An embedded system is the an embedded system is the unseen force behind some of the most innovative and intelligent devices we use every day, from smartphone and smart appliances to advanced medical devices and automotive systems. Embedded systems are the heartbeat that powers and controls them all. These specialized computers are designed to perform specific tasks with precision and accuracy, seamlessly integrating software and hardware to create responsive and reliable solutions. In a world where technology drives progress, embedded systems are the silent heroes making everything smarter, faster, and connected. Embrace the world embedded system where innovation meets functionality and the future comes alive in every microseconds. This is the this is the simple block diagram or architecture of an embedded system, which includes CPU, central processing units, and the basic building blocks of embedded system are sensors, microcontrollers, or any processing unit actuator. So embedded system integrates CPU, central processing unit, sensors, actuators, analog to digital converter, digital to analog converter, user interface, software, memory like RAM, ROM, and power units and other external blocks can be combined for advanced embedded system architecture. Here are the some examples of embedded systems which we use in day-to-day life, like mobile phones, tablets, washing machine, PC, laptop, TV, refrigerator, air conditioner, Wi-Fi modem, automatic features in car, digital meter, clock, thermometer, ATM machine, debit card swipe machine, pointers, traffic lights, and aeroplanes. And there are more embedded system too. So let's move towards our project requirements. So our objective is to create a simulation of an IoT-enabled home automation system. Our objective is to create a simulation of an Our objective is to create a simulation of an IoT-enabled home automation system that controls various home functions such as garden light, temperature regulation, and water tank management automatically and remotely via the Blynk platform. Key features of this project are garden light control, which automatically adjusts garden light based on ambient light level. And second one is temperature control system, which monitors and maintain indoor temperature with remote adjustment and energy efficiency through the Blink app. And the last one is water tank management, which automatically manage water level and pump control with manual override via the Blynk app. Tools required for creating this project are as follow. Simulation and development tools, which are software used to create this project. First one is PICSimLab simulator for simulating the hardware components and system behaviors. Next one is Arduino IDE, integrated development environment for coding and programming the microcontroller. Blynk app, Blynk app for creating a virtual interface to control and monitor the system. Virtual serial port for simulating serial communication between the hardware components and the software. Hardware components and hardware and components required for creating this project are: first one is LDR sensor. LDR sensor is used to detect ambient light levels for garden light control. LEDs to simulate garden lights, and temperature system includes heater and cooler to manage indoor temperature. Next one is LM35 temperature sensor for accurate temperature measurement. Cereal tank. Cereal tank is used to simulate tank to manage and monitor water levels. CLCD character liquid crystal display for displaying system status and data. Ethernet. Ethernet is used for network communication and connectivity to the internet. So first tool is PICSimLab. PICSimLab is used to simulate hardware components. It replicates the behavior of microcontrollers, sensors, and other electronics in a virtual environment, which reduces cost. So cost effective testing reduces the need for physical hardware, saving on project costs. Real time system analysis. Real-time system analysis allows developer to observe and test system responses to various inputs and conditions. It provides flexible development environment, supports multiple microcontrollers architecture for versatile project development, which is ideal for learning and prototyping, facilitates understanding of embedded system and helps refine designs before physical deployment. Next tool is Arduino IDE, Integrated Development Environment, a software platform for writing, compiling, and uploading code to microcontrollers like Arduino boards. User User-friendly interface simplifies programming, making it accessible to both beginners and experienced developers, which supports multiple microcontrollers compatible with various microcontrollers such as Arduino boards and ESP32, ESP8266, which has extensive libraries, offers a wide range of libraries for sensors, modules, and other components. Functionality. Streamline, Streamlined development combines all necessary tools for coding and debugging in one platform, making it ideal for creating projects. Extensive libraries of Extensive libraries offer a wide range of libraries for sensors, modules, and other components to enhance functionality. Streamlines development combines all necessary tools for coding, debugging in one platform, making it ideal for creating projects. Next requirement is Blynk app. Blynk IoT app, a mobile application for IoT, provides a virtual interface to control and monitor IoT devices and home automation system remotely, which has customizable dashboards, which allows to create interactive dashboards with widgets for device management. It also have real-time data monitoring system, which enables us, which enables user to view live data from sensors and devices, improving oversight and decision making. Remote access control. Remote access and control facilitates managing automation tasks from anywhere using a smartphone or tablet. Notification features sends alert and notification for specific events, enhancing responsiveness and security in home automation system. A Blink IoT app is look like this. So let's move towards hardware and components required to create this project. First one is LDR sensor. LDR sensor, which is used to detect ambient light levels to automate garden lighting based on daylight availability. LEDs. LEDs are used to simulate garden lights turning on or off based on LDR sensor data or manual control. Temperature system. Temperature system which integrates heaters, coolers, and LM35 temperature sensor to manage and maintain indoor temperature efficiently. Next one is cereal tank. Cereal tank which simulates the which simulate a water tank to monitor and manage water levels, preventing overflow or shortage. CLCD Character Liquid Crystal Display displays real-time system status and data for easy monitoring by the user. Ethernet 5500 facilitates network communication, enabling remote access and control over the internet. Features of the project. First one is garden light control, temperature system control, water tank management. So let's move towards first requirement of our project. The garden light control system uses an LDR sensor, light dependent resistor, and LEDs, light emitting diodes, to automate garden lighting based on ambient light conditions. This setup ensures that garden lights turn on automatically at dusk and turn off at dawn, enhancing efficiency, energy efficiency, and convenience. When the ambient light decreases, such as at sunset, the resistance of the LDR sensor increases. This changes is detected by the system, triggering the garden light to turn on. The LEDs acts as the garden lights in the system. Based on the signal from the LDR sensor, the LEDs are automatically turned off or on based on the value of LDR sensor. Next one is temperature control system. The temperature control system automatically manages heating and cooling using heaters and coolers to maintain a comfortable indoor environment. It operates based on inputs from an LM35 temperature sensor, turning the heaters and cooler on or off as needed. So how it works? LM35 sensor used to continuously monitoring the indoor temperature and sends data to the control system. Heater off or deactivates once the temperature reaches the desired level or exceeds the thresholds, ensuring energy efficiency. Remote control. allows user to manage temperature settings and monitor system status from a mobile app, providing flexibility and convenience. And the third one is water tank management. The water tank management system monitors and controls water levels in a simulated serial tank. It ensures optimal water usage and prevents overflow or dry condition through automated or remote management. How it works? We use serial tank which simulates we use serial tank which simulates a water tank where water levels are monitored in real time. Automatic management, pump control. It activates. The work of pump control is to activate or deactivate the pump based on water level to maintain optimal levels. Overflow prevention. Triggering alerts or shuts off, triggering alerts or shuts off the pump when the tank reaches maximum capacity to prevent overflow. Remote control. Users can also manage and monitor the tank remotely via an app like Blynk, allowing them to receive alerts and control the system from anywhere using through internet. Simulation images, which includes LDR temperature sensor, LEDs, temperature system, CLCD, Ethernet shield, and serial tank. We will also go through the simulation of this project. Now moving towards the conclusion of the presentation. This presentation provides a solution of monitoring and controlling home appliances and certain devices remotely using the Blynk IoT app and PICSimLab simulator. So, smart integration. The project combines PICSimLab for simulation, Arduino IDE for programming, and Blynk IoT app for remote control to create an advanced home automation system. Garden light control utilizes an LDR sensor and LEDs to automate garden lighting based on ambient light levels, improving energy efficiency and security. Temperature control system employs an LM35 temperature sensor along with heaters and coolers to maintain a comfortable indoor climate, adjusting automatically based on real-time data and allowing remote temperature management. Water tank management features a simulated serial tank for monitoring and controlling water levels, managing inlet and outlet valves to prevent overflow and ensures a steady water supply, all controlled via the Blink app. Enhanced living demonstrate the potential of Internet of Things to improve home automation through real-time monitoring, automation, and remote control, creating a smart and more efficient living environment. Thank you. Now we will see a real-time simulation of the project here. This is our PICSimLab simulator and this is PICSimLab spare parts. Now load the hex file. The This is the serial tank. We can see here temperature is 27.34 and volume is increasing. The inlet valve is automatically increasing because the volume is 2000 liters. Here we have LEDs, we have LDR sensors. We can see here the volume of the tank is full, so inlet valve is off. So inlet valve is off. For our first objective, The LDR sensor resistance is low, so LEDs are off. When we increase the LDR sensor resistance, LEDs on and LEDs will be on. Now we will showing the Blynk IoT app from where we will be controlling our temperature control system. We can see here green light is showing the on application is online. This is our Ethernet shield which is connecting our PICSimLab simulator to Blynk IoT app. The temperature is currently showing here is 27.34. If we if we switch on heater, if we switch on heater, the temperature on the CLCD is increasing, and when it reaches about 35, the heater is off. Heater will be off. Now we will on the cooler. We can see here our cooler is also working fine, and we can see the live status of CLCD as well. Now turning off the cooler. So this was our temperature control system. Now we will see our water tank control system. Now we will see the water tank control system. So if I press outlet valve on, we can see the water from the tank is decreasing, and when it reaches below 2000 liters, the inflow value is automatically on. I have to turn off I have to turn off the outlet valve, so the inlet valve is automatically turning. Now I have manually turned off inlet valve and start the outlet valve. Again, the water is flowing out of the tank, and when it reaches below 2000 liter, then let well it again automatically turn on. Now when the water reaches 3000 liter, or which is the full capacity of the tank, then inlet valve will be automatically turn off. Yeah, we can see here. So this is, yeah, we can see here. So this was my IoT based home automation project. Thank you very much, all of you.